In this video, we're going to look at computing the radius and interval of convergence for a power series using the root test. So in this one, we're asked to look at the radius and interval of convergence of the power series 1 to infinity, n to the n, x to the n. Now we could have used the ratio test as well, but in this case, since we've got our terms raised to the nth power, it seems just as easy, or perhaps even easier, to use the root test rather than the ratio test. So using the root test, we have limit as n goes to infinity, absolute value of the terms raised to the 1 over n power. Well, the absolute value doesn't affect the n to the n term at all, so we can get rid of the absolute value part on that. If we distribute the exponent to each of the powers here, we'll get just n, and then absolute value does affect the x because we could plug in positive or negative x's. So we just get n times absolute value of x. Now in this case, x is fixed. For a fixed x, what happens to the limit? Well, as n goes to infinity, for a fixed x, n going to infinity, this is going to go off to infinity, unless of course the x value was 0, and then all the terms were all 0 to begin with. So in particular, this limit does not exist unless the x is 0, so that tells us that the radius of convergence is 0. And since this power series is centered at 0, the interval of convergence is just the point 0.